Now we're going to learn how to do the derivative of a quotient of two functions. And it's one of the more complex derivatives we're going to learn. And it just takes some practice getting into a cadence with the formula, mastering your own mnemonic devices to remember it. So I'll try to point that out as we go. So we're going to look at the quotient rule, which tells us how to take the derivative of a quotient, okay? And it goes like this. So if I've got the derivative of one function divided by the other, so let's say we have f of x divided by g of x. Again, the names are arbitrary. We will often refer to the top as the top and the bottom as the bottom. Those might be better names for these guys. The derivative of a quotient is going to be this. You're going to start by looking at the bottom times the derivative of the top minus, which is different than the product rule where there's a plus, minus the top times the derivative of the bottom. And so at this point, it's similar to the product rule, except you've got a minus, which means that you can't switch these two values around because subtraction is not commutative. You can't change the order of subtraction because 5 minus 3 is not the same thing as 3 minus 5. So we can't do that. So it's very important you do the bottom times the derivative of the top minus the top times the derivative of the bottom. So that's one way to remember it. And then all of that is divided by the bottom. G of x is the bottom squared. Okay? So, again, we've got the bottom times the derivative of the top minus the top times the derivative of the bottom, right? This is t prime for derivative and b prime for derivative. So bottom times the derivative of the top minus top times derivative of the bottom over the bottom squared, okay? So that's typically how you might want to recite that to yourself. Another way is some people describe this as the low, the bottom is the low, and the top is the high. So you could say low, and then for derivative in this mnemonic device, you say low d high, so d for derivative, low d high minus high d low. So bottom is low, d high minus high d low over low squared. So that's another way you could remember that. I'm more inclined to do the bottom and the top because that's how I practiced a lot as a student. But do whatever works for you. Okay? So you need to know this derivative rule. Let's look at an example involving this rule now. Lots of algebra involved when you're doing these, okay? So if nothing else as a calculus student, you should come away as a really strong algebra student. So here we go. Let's put this in the context of a bigger problem. Let's do this. Determine the slope of the line, determine the slope of the line tangent to f of x equals 2x cubed plus 3x over x squared minus 2. Let's determine the slope of the tangent line to that function at the ordered pair. Let's see. Let's say x is 1, and then y in that case would be negative 5. All I did was plug 1 in for x, and I could see I'd get 5 over negative 1, which gives me negative 5, okay? But what I want is the slope of the line that's tangent to this curve at this point. And so if I want the slope of the tangent line, what I'm looking for is the derivative. I need to figure out, my goal is to get m, which in this case is going to be the derivative of f at the x value of 1. So I need to know f prime of 1, right? In order to do that, I'll get a formula for f prime of x. So let's look at f prime of x. And because f is a quotient of two functions, I have to use the quotient rule. Okay? So here we go. We're going to set it up. We're going to do the bottom, x squared minus 2. So that's the bottom, times the derivative of the top. Okay, I'm going to go ahead and do the derivative of the top. So the derivative of 2x cubed is, use the power rule, drop your 3 down and make this a 6, x squared, lower the power by 1, plus the derivative of 3x is just 3. So that's the bottom times the derivative of the top. Minus, again minus, not plus, minus the top, so that's 2x cubed plus 3x, that's the top, times the derivative of the bottom. Well, the derivative of x squared becomes 2x to the first, or just 2x, minus the derivative of 2, since it's constant, the derivative of 2 is 0. So I just get 2x minus 0, or I could just write 2x. And since I don't have anything added or subtracted, I don't have to put it in parentheses. Okay? So I've got the bottom times the derivative of the top, minus the top times the derivative of the bottom. All of that goes over the bottom squared. Okay? So this is the derivative of this rational function. Now, before I try to find f prime of 1, I'm going to go ahead and clean it up, although you could easily plug 1 into this. In fact, let's go ahead and do that. You could distribute all of this, combine like terms, and then plug 1 in. But since we're not going to be using this function for anything else, we're not going to be evaluating it for any other x value, let's just go ahead and find our slope, our f prime of 1. So m equals f prime of 1. Let's work down like this. So I get 1 squared minus 2. So 1 minus 2 is negative 1. Times 6 plus 3 is 9. Minus 2 plus 3. 1 is easy to plug in, right? That's why this is so easy. 2 plus 3 is 5. Times 2. So that's what I get on top. Over. 1 minus 2 is negative 1. And then squared. All right, so we have negative 9 minus 10, so that's negative 19. Negative 1 squared is positive 1, so we get negative 19 for m. Okay? And the question asks us for the slope of the tangent line, and this is the slope of the tangent line. This is our m value. It's the slope of the tangent line at this x value, and here's our generic slope that we could get if we wanted to plug any x value in. Okay? So we could take it further and find the equation of the tangent line. No big deal there. You could use your point slope formula or your slope intercept formula, whatever you like, and use this slope with this point to get the equation of the tangent line. But that's the product rule. You could mix this with lots of other rules. For example, here we just use the power rule. You could have the top or the bottom be a product, and you could mix the product rule in. Let's try one of those. Let's see how that goes. As you can see, the algebra can get rather complex. So it's vital that you be super neat and organized in your work. Otherwise, you're guaranteed to get lost. I'm always preaching to my students that when you get into these really lengthy sort of, especially algebraic, technical problems, it's important to go slow and double check as you go and make sure you're writing things out neatly. Going slower actually helps you go faster. If you try to go fast, you're going to make a mistake, you're going to get frustrated, you're going to have to start over. So just go slow and get it right the first time. So let's say, how about this? Let's write it this way. determine the derivative with respect to x of this quotient. Let's say we have z e to the z over z squared plus e to the z. Okay? So we've got some z's and 2's mixed in there, so don't confuse your z's and 2's. This is z squared plus e to the z. And I said the derivative with respect to x. Now, notice that there is no x here. So with no x, you would consider all of this to be a constant. There's no variables here because x would be considered the only variable. So with respect to x, all of this would be constant. The derivative would be 0. So I apologize. Let me say, I don't know why I switched variables there, but let's say instead we get something more meaningful and we want to determine the derivative with respect to z. Okay, so what we can do is, since we have a quotient, we can do the quotient rule. So d dz of this is going to be the bottom times the derivative of the top. So the bottom is easy. Z squared plus e to the z times the derivative of the top. Well, the top happens to be a product. So when I do this derivative, I have to use the product rule. So I'm going to set it up as such. The product rule says do something plus something else. So here we go. The product rule says take the first, which is z, multiply it by the derivative of the second, which is e to the z. The derivative of e to the z, luckily, is just e to the z. So that's the first times the derivative of the second, plus the derivative of the first. Well, the derivative of z to the first power is just 1. So this just turns into 1. The derivative of the first is 1. Multiplied by the second is e to the z. So I just get 1 e to the z, or just e to the z. Okay? So this is the bottom times the derivative of the top, which we had to use the product rule. We're not done yet. Now I've got to do minus the top, z e to the z, times the derivative of the bottom. Well, the derivative of z squared is 2z, plus the derivative of e to the z is e to the z. That's all over the bottom squared. Okay? And at this point, it would just be a matter of distributing and combining like terms. That's not my emphasis here at all. I certainly assume you could do that with no problem. So you could continue to simplify here. But my point was sometimes within the quotient rule or within some derivative rule, there will be another rule embedded. And so you've got to slow down and make sure to resist temptation and really pay attention to where the product rule might have to be implemented, for example.